Hello friends, in this session we are going to see the topics related to CSAT. More predominantly, you will observe the questions of factors and factorials in the exams like CSAT, EPFO, or in some cases CAPF as well. So what is the factor? What is the type of the questions that they ask under factorials? So we'll start with the factors first. Consider a number, say 24. If I ask you what all the factors of 24 are, so 24, you can just list down the factors. 24 will have factors 1, 2, 3, 4, 6, 8, 12, and 20. So as you can see, there are 1, 2, 3, 4, 5, 6, 7, 8 factors. So there are total 8 factors. If I ask you how many of these factors are going to be even number or odd number or composite numbers, prime numbers, you can answer anything now because all the factors are in front of your eyes. But if I give you a bigger number, say a number as big as 1440 or 19600, and if I ask you what is the total number of factors, then it is difficult to jot down all the factors and then count. So we have to have some method for that. And for that, we need to understand how the factors are formed or what all actual mean by factor. So 24 is a number which is a composite number. So it will have factors naturally. So when you write 24 numbers in its prime factorized form, it looks like prime factorized form means you have to break it till all the factors are prime. So 24, you can say 2 into 12 first. 12 yet not prime. So you can say 2 into 2 into 6. 6 again not yet prime. So 2 into 2 into 2 into 3. So this is what a prime factorized form means. That means we have 2, 2, 2 and 3. If you talk about the factors of 24, they can be made by this product here. I mean, if you pick only one of the twos, you will have one factor that is 2. If you pick only one of the threes, or there is only one 3, so if you pick that 3, so we'll have another factor that is 3. If you pick two twos, 2 and 2, so we'll have 2 into 2, 4 as a factor. If you pick one of the 3 and one of the twos, we'll have 3 into 2, 6. If you pick all 3 twos, we'll have 2 into 2 into 2, that is 8. If you pick 2 of the 2s and 1 of the 3s, so 2 into 2, 4 into 3, 12. If you pick all 2, 2, 2 and 3, we'll have the factor 24. And if you pick nothing of it, that means what remains is 1. So 1 is again the factor. That means the different combination of this product. So it's like you have 3 number of 2s and 1 number of 3. And what are the different combinations you can make out of these? 1, 2, 0 3s, 2 2s, 1 3s, 3 2s, 1 3s, 0 2s, 1 3s. So how many different combination you can make out of 2s and 3s? Those many factors we can have. So it's like saying that you have to make an alphanumeric code out of A, B, C, and 1, 2. Alphanumeric code. And in first should be alphabet, second should be a digit. So we have 3 alphabets, A, B, C, and 2 digits, 1 and 2. So how many different codes we can? So we can have A1. We can have A1, A2, B1, B2, C1, C2. So we can have total 1, 2, 3, 4, 5, 6 alphanumeric code. So how that 6 is coming? We have to realize there are total 3 choices for the first place. That means out of these 3, we can pick any. And out of these 2, we can pick any. So 3 against 2. All these 3, we have two choices. So 3 against 2 will have total 6. So that is why there are total 6 combinations made. So similarly, for 2, we have how many choices that we have to look for? So 2's power here is 3 because there are 3 2's and 3's power is 1. So for 2, we have total 4 choices because maximum power of 2 is 3. That means we can pick 0 number of 2, we can pick 1 number of 2, we can pick 2 number of 2, we can pick 3 number of 2. We cannot pick 4 number of 2s because we don't have 4 number of 2s. We only have up to 3 number of 2s. That means we have 4 choices to pick from 2. So we can pick 0 number of 2. That means we can pick 2 raised to power 0 or 2 raised to power 1 or 2 2s means 2 into 2. That is 2 raised to power 2. Or we can pick all 3 2s. So we have total 4 choices to pick from the power of 2s. Similarly, from the 3, we have two choices. Either we can pick no 3, that means 3 raised to power 0, or we can pick 1, 3. So this is how we have 4 choices to pick from the 2 side, and we have 2 choices to pick from the 3 sides. So 4 against 2 will have total 8 different combinations. For example, if I pick this and this, so their product 2 raised to power 0, 3 raised to power 0, which is 1, that is going to give you one of the factor. If you pick this and this, 2 raised to power 0, 3 raised to power 1, that will give you another factor, that is 3. If you pick this and this, 2 raised to power 1, 3 raised to power 0, that will give you another factor, that is 2. If you pick these two, 2 raised to power 1, 3 raised to power 1, we'll get another factor, that is 6. If you pick these two, 2 raised to power 2, 3 raised to power 0, that is 4. If you pick these two, 2 raised to power 2, 3 raised to power 1, that is 12. If you pick these two, 2 raised to power 3, 3 raised to power 0, that is 8. And if you pick these two, 2 raised to power 3, 3 raised to power 1, that is 24. So this is how these 8 factors are going to be formed with the combination of 2's powers and 3's different powers. So how many 2's power we have choices for? 4. And for 3's power, we have 2 choices. So total 4 against 2, we can have 8 total combination, and hence there are 8 factors. So this is how the factors are made. Factors are made with the help of combination of the prime factors. So now if I ask you, how many of these factors are going to be odd numbers? How many of these factors are going to be odd numbers? So for odd numbers, you have to see that we cannot have 2 into our product. We cannot have 2 into our product, because once 2 is entered, the number can't be odd. 2 into anything can't be odd. That means you cannot pick this, this, or this from the 2 side. We can only pick this. So we have only one choice to pick from the list of 2. But here you can pick anything, because only 2 is the prime number which is going to make our product as odd. Sorry, even. Only 2 is the even prime number. So if 2 enters our product, then only the product is going to get even. Otherwise, if there is no 2, the other prime numbers are going to be odd. So 3, 5, 7, 11. Let any number enter, any number of 5s, any number of 3s, any number of 7s entered, the product is going to stay odd. So that means for 3, we have all 2 choices open. So one choice from 2, that is 2 raised to power 0 only we have to pick, and 2 choices from 3. So 1 against 2, there will be 2 total combinations. That means 2 odd factors. So as you can see, 1 and 3, there are 2 odd factors. Similarly, if I ask you how many even factors are there, these are the odd factors. If I ask you how many even factors are there, so for even factors, for a number to be even, for the product like this to be even, we have to have at least 1 2 into it. You cannot pick 2 raised to power 0 now. You have to have at least 1 2 into it. That means you have to pick out of these 3. You cannot pick these. So for 2 side, we have 3 choices to pick from. We have to have at least one of the 2's in our product. And from 3 side, we have again both 2 open. Because once 2 is entered into the product, let any number of 3's, any number of 5's, any number of 7, any prime numbers, any number, let it come. The product is going to stay even, because we have already put at least 1 2, either 1 2 or 2 2's or 3 2's. So 3 choices from here, 2 choices from here, 3 against 2 will have total 6 combinations. And that is why there will be total 6 even factors. So as you can see, 1 2 3 4 5 6. These 6 are going to be the even factors. So this is how picking from different combinations, understanding what we exactly want to do. We have to make we have to count prime factors or composite factors, even factors, odd factors, square factors, cubic factors. We have to select the numbers, the prime factors and their powers accordingly. Okay, so we'll see one of the question where different kind of factors to be find. So this is a question. So first of all, this is a number. Is this in its prime factorized form? Yes, because 2, 3, and 5 all are prime. So this is the number in prime factorized form. So 2 raised to the power 4 into, sorry, 2 raised to the power 5 into 3 raised to the power 4 into 5 raised to the power 3 is the number. First question is to find the total number of factors. Do we know if the 2's highest power is 5, we have to increase this with 1 because to pick from, we'll have 6 total choices. From 0 to 5, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5. So we'll have total 6 choices of 2's to pick from. You can pick either 0 number of 2's, 1 number of 2, 2 number of 2, 3 number of 2, 4 number of 2, 5 number of 2. That means all you have to do is you have to increase this number with 1. So we'll have total 6 choices. Similarly, for 3, we'll have 5 choices. Either you pick 0 number of 2's or 1 number of 0 number of 3's or 1 number of 3 or 2 number of 3 or 3 number of 3 or 4 number of 3. So we have total 5 choices from here. And for 5, we have 5 raised to the power 0, 5 raised to the power 1, 5 raised to the power 2, 5 raised to the power 3, 5 raised to the power only up to 3. So we have total 4 choices, one more than this. So 6 against 5, against 4, so 6 into 5, 30 into 4, 120 will be the total number of factors. So we'll have total factors 120. So if you understood it very well, but even if you're finding this little tricky, because exams like CSAT, CAPF have other subjects to learn for as well. It's not only quant. So even if you understand how to find the number of factors, for now should be sufficient. All you have to do is convert a number into prime factorized form like this. And once you convert into prime factorized form, you have to increase the power of the primes with 111. So this 5 becomes 6, 4 becomes 5, and this 3 becomes 4, and do the product. These many total number of factors will be there. Now, they are asking, out of these 120 factors, how many factors are odd? So as we already discussed, we have total 6 choices to pick from the powers of 2. But if you want a factor to be odd, you cannot pick these 1, 2, 3, 4, 5 powers, because for a product to be odd, you cannot have any 2 into it. So you cannot have any 2. That means the only power of 2 you can pick is this. So we have only one choice to pick from. One from here. And once we pick 2 raised to the power 0, that means 2 is not going to enter our product. So all the 3's are welcome because 3 is not going to make our product even. And all the 5's are also welcome. So all 5 choices from here are open. All 4 choices are here from here are open. And from 2 side, only 1 is allowed. That is 2 raised to the power 0. So 1 against 5 against 4 will have total 20 factors which are going to be even. Oh, sorry, odd. So 20 factors are going to be odd. And similarly for even, either you can do this total 120 minus 20 odd, remaining have to be even. So you can do like this 100. Or for a product to be even, you have to have at least 1 2 into your product. So that means you can pick from either of these 1, 2, 3, 4, 5. So from 2 side, now we have 5 choices. And once the 2 is entered into the product is already even. So any number of 3's, any number of 5's, it's not going to make any change. The product will still stay even. That means all the 5 3's are available. All the 4 5's are available. So 5 into 5 into 4, that is 100. So there will be 100 even factors. So you should be able to calculate total number of factors, number of odd factors, number of even factors. And number of composite factors also equally important, but it's very easy. For these numbers, how many composite factors are there? So, you know, this number will have how many prime factors? If I ask you how many prime factors are going to be there. So there are only 3 prime numbers in its prime factorized form. It doesn't have 7 into it. It doesn't have 11 into it. It doesn't have 13 into it. So because it has only 2, 3, and 5, that means only 3 numbers, 2, 3, and 5. Those 3 are going to be its prime factors. So this number will have only 3 prime factors, that is 2, 3, and 5. So out of 120, only 3 are prime. But that does it mean that out of 120, if 3 are prime, 170 are composite, 117 are composite? No. Because we have counted 2, 3, 5, but we have not considered the 1 yet. 1 is also the factor. 1 is factor of every natural number. But 1 is neither prime nor composite. So in the list of composite, we are not going to count 1 as well. So we are not going to count 1 and these 3 which are prime factors. So 3 prime plus 1, 4 we are going to leave out of 120. So remaining 116 number of composite factors will be there. E, find the total number of factors of n which are multiple of 5. Now it is as good as finding the even factors, because a number to be even, what do you mean by even number? Even number basically means a number should be multiple of 2. A number should be multiple of 2. That means it has to have at least 1 2 into it. So if you want a number to be multiple of 5, that means you want at least 1 5 into it. So 5 raised to power 0 this time is not allowed. We have to have at least one of the 5. So from the powers of 5, we have these 3 options to pick from. This we cannot pick, because if you pick 5 raised to power 0, that means you are not picking any 5. Your number is not going to be multiple of 5. So that means 5's available power are only 3. And once you pick one of the 5's, all the 3's and all the 2's, they are welcome, because already we have made the multiple of 5. So 6 into 5, 30 into 3, 90. 90 of these 120 factors will be multiple of 5. Total number of factors of n which are multiple of 15. So what you can do for this is, 15 means what? 15 is 3 into 5. So we have to have at least 1 3 and at least 1 5 for a number to be multiple of 15. 15 is, for 15 you have to have at 1 3 and 1 5. So you cannot pick 0 number of 3's and 0 number of 5's. So that means from the 3 side, we have 1, 2, 3, 4 choices to pick from. And from the 5 side, we have 1, 2, 3 choices to pick from. We have to have at least one of the 3 and at least one of the 5's. And from 2 side, all 6 choices are open. 6 into 4, 24 into 3, 72 will be multiple of 15. So either you can do it like this, but there is another trick as well. So if you don't understand this, because every time it's not going to be as easy as 15. Sometimes it can be 45, 90. Any number can be asked, multiple of 90, multiple of 45. So what you can do is, you can just divide the said number with 15, because you want multiple of 15. So divide it with 15. 15 is nothing but 3 into 5. So one of the 3 will go, one of the 5 will go. So 3's power will remain 3 and 5's power will remain 2. And then find the number of factors of this. So number of factors of this will be 5 plus 1, 6, 3 plus 1, 4, and 2 plus 1, 3. So 6 into 4 into 3. So as we did, it is going to be 72. Okay, so this is another trick to do that. This is, of course, understanding why is important, that why are we doing this? Why are we dividing this? Because we are cancelling 1 power. So we are making, instead of 4 3's, 3 3's, and instead of 3 5's, we are making 2 5's. So why we are doing this? Because this power 0 and 0 not allowed. So understanding is important, but this is the trick for you. I hope you got this. G. G is important question, a little different, but very, very important for us. Now, G question says, how many factors of this number are perfect squares? So for a number to be perfect square, we have to have even power of the primes. That means if I say 2, is it a square number? No. If I say 2 into 2, is it a square number? Yes. If I say 2 into 2 into 2, is it a square number? No. Because these 2 and 2 will make a pair, but these 2 doesn't have pair, partner. So it can't be a perfect square. If I say 2 into 2 into 2 into 2, then it becomes perfect square. 16 is a perfect square because it has perfect pairs of prime factors, proper pairs of prime factors. So that means the power of 2 should be either 2 or 4 or 6. That means even power, so that the proper pairs will be formed. So only allowed powers from these prime factors are going to be the even power. So 2's available power we are having right now are 0, 1, 2, 3, 4, 5. But we are allowed only even power. 0 is also even in this case. So from 2 side, we can pick this, this, and this. So we have 3 choices to pick from 2's powers. From 3 side, we can pick this, this, and this. So we have total again 3 choices to pick from. From the 3's power, these 3 are even. And from the 5's side, we have this and this. These 2 even powers of 5. 3 against 3, 9 into 2, 18 of these factors are going to be the perfect square numbers. Because we have picked only even powers of 2, 3, and 5. So 2 into 2 into 3 into 3 into 3 into 3, if I write, is it a perfect square? Yes, because we have picked even power of 2, 2's power 2, and 3's power as 4. So yes, this is going to be a perfect square because proper pairs will be formed. So even numbers or even powers of these prime factors are allowed. That is why we have picked only even powers. Similarly, for a number to be a cubic number, multiple of 3 are allowed. That means if I say 3, is it a cubic number? No. 3 into 3, is it a cube? No. 3 into 3 into 3, it's a cube. So that means the power should be multiple of 3. So power should be either 3 or 6. So from the 2's side, this is allowed. 0 is a multiple of every number. So if we are looking for multiple of 3 as a power, 0 is also welcome. Because 1 is a cube, 2 raised to power 0 is 1. 1 is a cubic number, right? 1 is a cube, 1 is a square, 1 is a power 4, 1 is a power 5, 1 is everything in that manner. So that's why power 0 is allowed. And then multiple of 3 means 2 raised to power 3 is allowed. So we have only 2 choices to pick from the power of 2's. From the 3's, 3 raised to power 0 is allowed, 3 raised to power 3 is allowed. So here also we have 2 choices. From the 5, 5 raised to power 3 and 5 raised to power 0 and 5 raised to power 3. These 2 are allowed. So 2 into 2 into 2. There will be total 8 factors which are going to be the cubic numbers. Find the total number of factors of n which has unit digit 0. Unit digit 0 means what? When a number has unit digit 0, when it is a multiple of 10. Whenever a number is multiple of 10, it will have unit digit 0. So that means we are looking for a numbers which are multiple of 10. So like we did in this case and this case, if you want a number to be multiple of 10, we can just say 2 raised to power 5 into 3 raised to power 4 into 5 raised to power 3. We divide it with 10, and 10 means 2 into 5. So 1 2 goes off, 1 5 goes off. So remaining power will be 4 from here and 2 from here. And find the number of factors. So this 4 becomes 5, this 4 becomes 5, and this 2 becomes 3. So 5 into 3, that is 75 factors of these numbers. After cutting down the 10 from it, that means the multiple of 10 will be 75. The factors which will be multiple of 10 are 75. Similarly, find the total number of factors of n which have last 2 digits 0. So if any number has last 2 digits 0, means it is a multiple of 100. So we are looking for multiple of 100 now. So for multiple of 100, you have to divide this number with 100 and then check the number of factors for that number. So if this is a number 2 raised to power 5 into 3 raised to power 4 into 5 raised to power 3, we have to divide it with 100. 100 means 2 raised to power 2 into 5 raised to power 4 into 25 is 100. So 2's 2 power will go off, remaining power will be 3. 5's 2 power will go, only power remaining will be 1. And we have to find the number of factors of this. So this 3 becomes 4, this 4 becomes 5, and this 1 becomes 2. Increase everything by 1, 1, and 20 into 2. There will be 40 numbers which are going to be multiple of 100. Find sum of all factors of n. So for sum of all factors of n, we can take another example for now. Small example so as to understand how to find the sum. Let's take the example of 24. We know 24's prime factorized form was 2 raised to power 2. 2 raised to power 3 into 3 raised to power 1. This was the prime factorized form of 24. And all the factors form were 2 raised to power 0, 3 raised to power 0, 2 raised to power 0, 3 raised to power 1. 2 raised to power 1, 3 raised to power 0, 2 raised to power 1, 3 raised to power 1. 2 raised to power 2, 2 raised to power 2, 2 raised to power 3, 2 raised to power 3, 3 raised to power 0, 3 raised to power 1, 3 raised to power 0, 3 raised to power 1. So those were 8 factors. If I have to add all these factors, so I can add this row and this row. So when I add the first row, I can take 3 raised to power 0 common. And what remains inside the bracket is 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3. And from the lower row, I can take 3 raised to power 1 as common. So what remains is 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3. And now from these two brackets, I can take 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 as common. And what remains inside the bracket will be 3 raised to power 0 plus 3 raised to power 1. So that means in separate brackets, you have to add all the available powers of these factors. This is what a sum of factors will be. Of course, calculation might take a little time. So they can't be asking you exact answer. They can just put the options like this. In this case, it is easy to find the sum. But in every case, it might not be easy. For example, a bigger number like this. So they can just give you the bracket like this. So all you have to do for a bigger number like this is just add all the available powers of this prime under different brackets and multiply those brackets. For example, this is 2 raised to power 5. So you'll write 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 plus 2 raised to the power 5. 0 to 5. Then for 3, you will write 3 raised to power 0 plus 3 raised to power 1 plus 3 raised to power 2 plus 3 raised to power 3 plus 3 raised to power 4. 5's 0, 1, 2, and 3. So this is how you will just add available powers under different brackets and multiply these brackets. This is how you find the sum of the factors. So this is going to be the answer to this question. And product is again easy. Again, I'll take the example of number 24. So we know for a number 24, we had the factors like 1, 2, 3, 4, 6, 8, 12, 20. There were these 8 factors. So if I ask you what is the product of all these numbers, so we can say this into this is 24. So 124 is formed out of 1 into 24. 2 into 24 will give me another 24. 3 into 8 will give me another 24. And 4 into 6 will give me another 24. So there are 4 number of 24s. That is 24 raised to the power 4 is the product of the factors of number 20. So because there are total 8 factors and 2 factors multiply with each other to form the number 24, that means if there are 8 numbers, there will be 4 pairs. And that is why 24 will appear 4 times. So the general form will be, if you want to find the product of all the factors of n, it will be n raised to the power number of factors divided by 2. As we did in this case, because 2 factors will combine to form that number. So if number of factors are 8, there will be 4 pairs. That's why you have to divide it with 2. So number of factors we already calculated 120. If this is the number n, so you just write that entire number n and the power will be 120 by 2. That is n raised to the power 60. This will be the product of all factors of number n. So even if you understand these many questions should be sufficient for this topic factors. Let's solve some question based on it. Find the smallest number by which 13,500 should be multiplied to make it a perfect cube. So now if this is a number, first we have to consider its prime factorized form. So first of all, 135 is 45 into 3 into 100. 45 is 9 into 5. So 9 means 3 raised to power 2 and this one more 3. So 3 raised to power 3 will be there. This is 5 and 5 raised to power 2. So 5 raised to power 3 will be there. 2 raised to power 2 will be there. So this is a prime factorized form of this number. You can do little more practice to get it accurately and quickly, little more quickly. Because every time you can't just start breaking 2 into something, then again. So you should be able to do it little fast. We have to find the smallest number by which this should be multiplied to make it a perfect cube. A number is perfect cube if all the powers of all the primes are multiple of 3. This is multiple of 3, yes, this is multiple of 3, but this is not yet multiple of 3. So to make it multiple of 3, that means to make 2's power 3, we'll have to multiply one more 2 into it. So that means we have to multiply 2 into it. Once we multiply 2 into it, it becomes 27,000, which is a cube of 30. So it will become 30's cube once we multiply 2 into it. So answer is 2. The smallest number to be multiplied is. Let's see the next one. By what least number you should divide this so as to make a perfect square. So 1568, first if we had to write the prime factorized form, it could be 4 into 4 3s are 12, 4 9s are, 4 2s are. Again, we can multiply it with 4. 4 into 4 times 9s are 8s are. Again, we can multiply it with 2. 2 into 49. So now we know this is 2's power 2, 2 and 2. That 2, 2 and 1, that is 2's power 5 into 7 raised to power 2. So this is the prime factorized form of this number. By what number you should divide it so as to make a perfect square? A number is perfect square if all the powers of primes are even. This is already even. This is not yet even. So if we have to make it even, so you'll have to divide it with 2. Once you divide it with 2, the power will become 4. So then the answer should be 2. If you divide it with 2, it becomes 784, which is a square of 28. So that means 2 is the number. Easy? We are to answer the number of factors of the following number. Also, how many of them are non-prime factors? So 1268. Prime factorized form will be, it is divisible by 4. So 4 times 317. 317 is now divisible by, is it a prime? So yes, this is a prime number. So that means the prime factorized form will be 2 raised to power 2 into 317 raised to power 1. We have to find the number of factors. So, you have to increase this by 1 and this by 1. So this 2 becomes 3, this 1 becomes 2. There will be total 6 factors. Out of which how many non-prime? So, there will be 2 prime factors, 2 and 317. There will be 2 prime factors. If you subtract the prime factors, the remaining will be non-prime factors. So there will be 4 non-prime factors of this number. 345, the prime factorized form will be, this is multiple of 3. So 3 into 115. 3 into 5 into 23. So all these are prime now. So this is a prime factorized form of this number. Number of factors will be, increase this with 1, increase this with 1, increase this with 1. So 8 will be the total number of factors, out of which 3, 5 and 23 are going to be the prime factors. So remaining 5 factors will be non-prime factors. Lastly, 600. 600 is 6 into 100. So 2 raised to the power 3 into 5 raised to the power 2 into 3 raised to the power 1. 6 into 100. This is the prime factorized form. So you can just increase the powers with 1. This will become 4. This will become 3. This will become 2. So 4 into 3 into 2. Total 24 factors are there, out of which 2, 5 and 3. 3 are the prime. So remaining 21 will be non-prime factors. Easy? Some of the all factors of the following. So I hope you know that now you can do it as a practice. But once we do the prime factorized form, like we did in the previous question, same numbers, all you have to do is add all the powers of all the factors in separate bracket and multiply those brackets. In how many ways 360 can be written as a product of two natural numbers? So 360 can be written as a product of two natural numbers. I'll take the example of 24 again. So 24 is 24's factors are 1, 2, 3, 4, 6, 8, 12, and 24. So if I ask you, how many ways 24 can be written as product of two numbers? So we can write 24 as 1 into 24, 2 into 12, 3 into 8, 4 into 6. So we can write a number 24 as a product of two numbers 4 ways. 1 into 24, 2 into 12, 3 into 8, 4 into 6. Because there are 8 factors and 2 factors make a pair to form the number. So there will be total 4 ways to write that. That means the number of factors by 2. So all we have to do is find the number of factors of 360 and divide it by 2. So the answer for such questions will be number of factors by 2. So 360's prime factorized form is 2 raised to the power 2 into 3 raised to the power 2 into 2 into 5. That means 2 raised to the power 3 into 3 raised to the power 2 into 5 raised to the power 1. This is the prime factorized form of 360. So number of factors will be 3 plus 1, 4, 2 plus 1, 3, 1 plus 1, 2, 12 into 2, 24 total number of factors. So number of factors are 24 upon 2, that is 12. So there will be 12 ways with which you can write 360 as a product of two numbers. Easy?